T2 over the temperature T2. Now, how can we combine now the Boyle's law and the Charles' law? That is making a combination of the Boyle's law and the Charles' law. We are going to combining Boyle's law and the Charles' law. Boyle's law and the Charles' law. The combination of this law, it will give us a law which of this format. We are going to have the pressure P1 times the volume V1 over the temperature T1 should be equals to times the volume V2 over the temperature T2. And from here, we can be able to observe that this will give us a constant. And this as well as a constant, means this constant is equals to this constant. And from here we can see that the product of that is the expression pressure times volume over the temperature will be always a constant. It's always a constant. This is always a constant. You can see that this is always a constant, and this constant is given as R. This will imply that this pressure times volume over the temperature will be equals to R, and this R is known as the universal gas constant, where R here is equals to universal gas constant. R is equals to universal gas constant. And now, how do we say, if now for n moles of a gas, now if we are working for n moles of a gas, you imply that the pressure P times the volume V over the temperature T should be equals to nR for n moles of a gas. This should be for n moles of a gas. And making PV the subject of the formula, you imply that PV should be equals to nRT, where P is equals to the pressure of the gas, V is equals to the volume of the gas, N is equals to number of moles, N is equal to a number of moles. Universal gas constant, as already said above, universal gas constant YT is equals to the absolute temperature. That means temperature in Kelvin. Now from here, this equation PV equal to nRT is called the ideal gas equation, where this equation PV, the equation PV equal to nRT, is the ideal gas equation. And now there is something very peculiar. When you look at this equation, you see that all the three laws stated above, they exist mindfully in the equation. Now, for example, we can see that for the Lucas law, the pressure is always directly proportional to the temperature. For the Charles' law, the volume is directly proportional to the temperature. And then for the Boyle's law, the pressure is inversely proportional to the volume. This is if we divide all through here by V, or we divide all through by P, you see that once we divide all through by V, once P is increasing, V is decreasing. Or if you still divide all through by P, you see that once V will be increasing, P will be decreasing. So you can see that this is the ideal gas equation. The Boyle's law, the Charles' law, the Lucas law, they show their manifestation in this equation. Now, this is all we need. This is the universal this is the ideal gas equation, and from this equation we can be able to solve many problems that concerns ideal gases. But before we can see on how we can manipulate